All right, so how do we find the mean and standard deviation of a frequency table or group data? So the original problem here, let's see, I think I've got it right here, was if we had if we had those scores were they were grouped, their bins here in this problem are grouped between 61 and 70 and 71 to 80. So one thing I'm noticing about these classes, or the class width, is that it's going up by 10. Notice that I'm going down to do this, not going across. If I want to go across, I've got to remember that I'm including these numbers. So there'd be 61 all the way up to 70, which is 10 numbers. I don't want to just think about subtracting. But if I go down, I can see that these are incrementing by 10 each time. So that tells me these bins are 10 units wide. So the midpoint would be half of that. So 5. So I'm going to add 5 to the lower number. And that's where I came up with the 66 and the 76. And notice those are just going up by 10. And of course, those are the frequencies. So what I did is I started setting up the spreadsheet. Then I realized I probably ought to talk about how do you do this with brute force. Now, how do we do this? By listing out all those numbers. Not something we want to do, but we can. There's only 20 numbers here, so that's not too bad. So I'm just going to go ahead, and if you don't mind me typing for a minute here, and I'll try to talk while I'm doing this. I'm seeing 2 66s. I'm seeing 8 76s. And now that I got 4 of them, I'm just going to copy and paste. And then I've got 7 86s. So 86, 86, 86. And I'm going to paste that down there. And that's 6. I need 1 more 86 for the 7 of them. And then I need 3 96s. And now that I've got the numbers, I mean, I could just use the built-in. I could certainly go through and use the formulas. I think at this point in this course, for small data sets, yes, I feel okay asking you do those questions. But with larger data sets like this, that's a pain. So I'm going to let the spreadsheet do this, and you can use a calculator, you can use an applet. You know how you get that, the answer wouldn't matter. So there's the mean of those numbers, and to get standard deviation with a spreadsheet. Now I don't know if you've watched anything else I've done or seen anything else anybody else has done, but to get the standard deviation, you do equals STD. There's all kinds of different standard deviations. I'll be honest with you, folks, I haven't bothered to learn them. I know this is the sample standard deviation. That's what I want. And I'm going to select all those numbers. And that's what the built-in formulas, let's see. So this is the standard deviation. This is what the built-in formulas are telling us. How do we do it from just a frequency table? Calculators will do this for you. There's a way to do that. You can certainly go find it online. So the theory behind it, though, is instead of listing out all those numbers, I'm just going to multiply the 66 times the 2, and that will give me 2 66s. Same thing, 8 76s, 8 times 76 is that number. And I found the sum. I found the sum of all those products. I found the sum of how many numbers there are. There's 20 of them. And I divide them. I got 81.5. Is that what I got when I did it this way? 81.5. So that's good. That came out to be the same. Now what we got to worry about is to get the standard deviation. And that it's not bad. It's just there's a something you have to consider, and which will help you later on when we start looking at probability distributions, because finding the mean and the standard deviation of those is very similar. So the first thing to do when you find a standard deviation is remember to do the number minus the mean. We're going to find how far apart they are. So the number I'm actually looking at is 66, and the mean I know is 81.5. So there's a lot of ways you can do shortcuts. I'm just going to do this shortcut. I'm going to click on the 66. That'll get that cell. I'm going to subtract my 81.5. There's ways you can lock in cells. I don't really want to go here or there. So that's that difference. And then I'd have to do the same thing, 76 minus 81.5. I'm going to get very lazy and let the spreadsheet do this. I'm assuming you don't know how to do this. So if I go down to the bottom right-hand corner of the cell. Do you see the way my cursor goes to a plus sign? That just lets me drag it and fill it down. And you can double click on the cells and see what it did. Okay, so those are the x minus the x bars. So now the next part of the formula in the standard deviation, I won't write it here. I know it's in the textbook and I've done this elsewhere. I'm going to do x minus the x minus the mean, x minus x bar, and then I'm going to square each of those differences. Because if I just find the sum of these differences, it'll be 0. And if it's not 0, it's because of rounding issues. So I'm going to square each of these numbers. I just did that by doing equals, and I clicked on the cell I want to raise to the second power, and I do caret 2 or shift 6 and then 2, and that squared that number. And again, I'm going to do that fill down trick. Now what I need to consider, what I haven't even looked at in this calculation, is the frequencies. There are 2 of these 240s and 8 of these 830.25s. So that's what I'm going to do, is I'm just going to multiply each of these squared differences times the frequency. So equals, I'm going to do 2, or click on the cell that's got the 2, shift 8 times the cell with the squared difference, and that'll do that multiplication for us. And then I'm going to fill down. I'm going to fill that down, go to that little plus sign. So now here are all the squared differences for all 20 numbers. So now I'm going to do some sums. Well, I already know that there's 20 cells. I'm going to be a little lazy and just do it, or maybe be a little repetitive and do it here. So that cell, those should add to 20. And then I'm going to can do the same thing over here underneath this cell here, but I'm actually just going to do a Control-C, Control-V to copy paste it, and look what it does. Now I can find the variance. The variance is this sum here, that sum of all those square differences divided by, for the sample variance, we're going to divide by 19, which is 1 less than the number of numbers we had. And that's it. Then to get the standard deviation, we're going to take the square root. So equals, start typing in SQRT. That's for square root. And I'm going to take the square root of that number. And that says 8.7, 8.87. And the built-in formula said 8.87. So certainly can do it this way. It's not wrong to do it this way. If there's hundreds of numbers, though, you don't want to have to type out all those numbers. This way is not too bad. Okay, so hopefully that helps you build some understanding about what's going on with the standard deviation and with these group data tables. And that hopefully will help you in the future when we look at probability distributions.